derivative, as a verbal definition, the derivative is the rate of change. That's an important concept. It's a rate of change of one quantity with respect to another quantity. Okay, what do we need by that? As we change one of these quantities, another thing is changing, and that rate of change is what we can calculate using the derivative. Examples of that are things like speed, rate of change of distance with respect to time, flow rate. So you've got some liquid flowing out of a reservoir or tank, and the flow rate can be measured. So it's the rate of change, so it would be megalitres per hour if it was released from a dam, etc. Acceleration, and that's rate of change of velocity with respect to time. Speed is rate of change of distance with respect to time or displacement. So those are some examples of rates of change, and we can use the derivative to actually calculate these rates of change. All right, so let's just start with something quite easy. Say we've got S, the displacement, is equal to 2t plus 3. So S is in metres. So you have some objects moving so that it's, we'll forget about the differences between distance and displacement. We know there is from our work with vectors, but we'll just use distance here. So S is distance in metres and T is in seconds. Okay, so we could draw a distance time graph. And we know from our knowledge that this is in the form of y equals mx plus c, and mx plus c takes the form of a straight line. C is the y-intercept, so we're cutting at 3. So we'll go up 4, 8, and 12. Let's just do over the first 4 seconds. And this will be, S is a common abbreviation for distance or displacement, so that'll be in metres. Now we know from our knowledge that it'll cut the y-axis at 3, and we know it's a straight line, so when we put a 4 in there we get 11. So we get that. So this is describing graphically what happens over the first 4 seconds. So we can calculate it when t is equal to 1. And if we knew that the object started 3 metres away from the origin, we can see how far it is away after 1, 2, 3 and 4, and anything in between there if you like. Now, if we wanted to know the average speed for the first 4 seconds, it'll be just distance over time. And we know that it has travelled from 3 up into 11, so that point there will be 11, and this point here will be 3. So it'll be 11 minus 3 over 4 minus 0. So that'll be 8 over 4, which is equal to 2 metres per second. So that was its average speed over the first 4 seconds of travel. If we look at this up here, we've got distance over time. So we actually calculated, this was the distance, and this was our time.